Let's take a look at an example problem from Module 8 for ME 270 Structural Dynamics. So in this example problem here, we're going to figure out how to replicate a step wave. So we can see here we have the step wave on our x-axis. Over here we have time, and on our y-axis here we have our p of t function. You can see we go up to some level p naught here and a negative p naught over there. And we have a period here shown as our t1. Now, we also know here we have our p of t. For our negative p naught here, goes from here of t value of negative t1 over 2 up to 0. And for our p naught here, from 0 to t1 over 2. So let's write out our setup page here. So for this example, we're asked to determine the expressions for the coefficients of a real Fourier series representation of a square wave that we saw on the first slide there, and we've drawn below again here now. So again, p of t on our y-axis, t on our x-axis here. There's our period t1. And there's our values here for our time for our negative p naught and our p naught. So what we're going to look for is for part A, we're going to find the coefficients. So that would be our a naught, a sub n, and b sub n. And for part B, we're going to plot the truncated series employing respectively 1, 2, and 3 terms of the Fourier series. So before we begin our solution here, we want to take a look at our key equations. So we know we're going to need our coefficients, our a naught, our a sub n, and our b sub n. And we can go to equation 7.4 in our textbook on page 185 to get these. So I've written them out by hand here. Our a naught is equal to 1 over t1 times the integral from negative t1 over 2 to t1 over 2 of p of t dt. So we'll call that equation 1 there. Our a sub n equation here, we have our 2 over t1 times the integral from negative t1 over 2 to t1 over 2 of p of t times the cosine n of our omega 1 t dt. We'll call that equation 2. And our b sub n equation here is 2 over t1 times the integral from negative t1 over 2 to t1 over 2 of p of t times the sine times n, or omega 1 times t dt, and this will be our equation 3 here. Now we can recall for our omega 1 that we're seeing in both of these equations for a sub n and b sub n, this comes from this expression here that omega 1 is equal to 2 pi over t1, which comes from equation 7.3 in our book. Now down here on the bottom right of the slide, I've typed these out as well. It's a little bit clearer to read, and you can reference back to these. And this is a great problem to reference back to if you ever need to look at these equations from 7 and 4 on page 185 of our text. A naught, a sub n, b sub n, and our omega 1. So now we have one page that we can reference back to for all our key equations as we begin the solution to this problem. So as we start our solution, we can evaluate the integrals from our equation 7.4 over the given period here from a negative t1 over 2 to a t1 over 2 for our t value here. Where again, we were given this p of t right here for our negative p naught and our positive p naught over here. So again, for negative p naught, we have negative t1 over 2 to 0. And for p naught, we go from 0 to t1 over 2. And we can get that again from our graph. We can confirm that. And we also now have this expression here that we showed in the previous slide here that omega 1 is equal to 2 pi over t1. So now we can take this equation 4 here and put it back into equations 1 and 2, which came from that equation 7.4 in our textbook. So that's what we do here. We go back, we reference equation 1. That's our a naught equation here from 7.4 in our text. 1 over t1 times the integral from negative t1 over 2 to t1 over 2 of p of t dt. So then we can plug into this guy here. So we can say, okay, let's do this out. So a naught is equal to a negative, when we do out our integral here of p of t dt, 1 over t1 times p naught t evaluated from negative t1 to 0 plus the other side of it here, 1 over t1 times p naught t from 0 to t1 over 2. So we have those two time frames again from this down here. So we can change that out as we do our integral here and evaluate it that way. So we do that out here, and what we find out then is our a naught is equal to 0. So if we continue going on here to prove that, we show now, okay, negative t1 over 2 all over t1 there times our p naught plus our t1 over 2 over t1 times our p naught there. So we can look here, our t1 cancels with our t1 there, t1 cancels with our t1 there. We're left with 1/2 p naught minus 1/2 p naught, which is a 0, which again, how we end up with our a naught is equal to 0 there. So then we move on to our a sub n expression here. A sub n in our general form from 7.4 is 2 over t1 times the integral of negative t1 over 2 to t1 over 2 of now p of t times the cosine times n times our omega 1 times dt, where again we have our omega 1 here of 2 pi over t1 that we can sub in for our omega 1 up here. And again, it's the same intervals here for p naught, negative p naught and p naught there. So we can plug into a sub n and integrate. So we do this step by step. A sub n is equal to negative 2 over n times our omega 1 t1. We pull out our constants and do our integration. P naught times the sine of n omega 1 t. Evaluate, again, we break this up. First, we go from our negative t1 over 2 to 0. Then we do the other side over here. We have 2 over our n times omega 1 t1 p naught times the sine n omega 1 t, evaluated now from 0 to t1 over 2. So again, we break that one up just like we did before. We'll go back through. We'll simplify things down, see what we can cancel out here. So we go through, cancel out some t1s, cancel out some 2s here. Come over the other side, still cancel out that 2, that 2, that t1, that t1 there. We can reduce and simplify. Once we do that, do out our limits as well here, where it's evaluated from for both those sides. We end up with our a sub n is equal to a negative 1 over pi n p naught times the sine of n times 2 pi over t1 times a negative t1 over 2 plus 1 over pi n times our p naught times the sine here times n of a 2 pi over t1 times t1 over 2 there. So we start going through. T1 cancels with t1, 2 cancels with our 2 there. Again here, t1, t1, 2, and 2 all cancel out. So now we can reduce and simplify even further. So our a sub n is equal to a negative 1 over pi n times our p naught times the sine n pi plus 1 over our pi n times p naught times the sine n pi there. So we can notice here we have a negative with this whole function here and a positive with this whole thing here. Those two will cancel out, which means also now our a sub n is 0. So we have our a not 0 and we have our a sub n is 0. So now we'll go on to the third one. So now we move on to our b sub n. So our general equation for b sub n is 2 over our t1 times the integral from negative t1 over 2 up to a t1 over 2 over here times our p of t times the sine n pi 1 t dt, where again we have this expression here. We know for our omega 1 that we can plug in up here is equal to 2 pi over t1. And we have our p of t. We can break into these two segments here for p naught and negative p naught. So we can plug that in, do out our integration. We end up with the expression here that this is equal to, for b sub n, of 2 over n times omega 1 t1 times p naught times the cosine n omega 1 t, evaluated now for the first half here, negative t1 over 2 to 0. And this is minus on our right-hand side, 2 over n omega 1 t p naught cosine n omega 1 t, evaluated now from 0 to our t1 over 2. And again, now we have this expression here for omega 1 that we can plug in here as well. There, there, and there as well. So once we plug these in, we have our b sub n is equal to 2 over n times 2 pi over our t1 times p naught times the cosine of n times 2 pi over t1 times t, evaluated from negative t1 over 2 to our 0, minus 2 over n times 2 pi all over t1 times p naught cosine n 2 pi over t1 times t, evaluated from 0 to t1 over 2. And as you all can already see, we're starting to cancel. Our 2 cancels with our 2, t1 with our t1, 2, 2, t1, t1, reduce and simplify. Our b sub n is now equal to 1 over n pi times our p naught cosine n times 2 pi over t1 times negative t1 over 2. So again, our t2 and our 2 and our t1 and our t1 are going to cancel there. Minus 0 here. Minus 0 minus a 1 over n pi times p naught cosine n. Again, now times 2 pi over t1 times t1 over 2, where the t1s are going to cancel and our 2's are going to cancel there, which again simplifies down even further. So b sub n is equal to a negative 1 over n pi p naught cosine n times pi minus 1 over n pi times p naught cosine n pi there. So now minus and a minus, these are going to add together. So now we don't have a 0 for our b sub n, but we do have for our b sub n here is this is equal to negative 2 p naught over n pi times the cosine of n pi minus 1. So from equation 7.2 on page 185 of our text, we have this relationship here that p of t is equal to, now we can plug in all these coefficients, our a naught plus our epsilon from n equals 1 to infinity of a n times the cosine n of omega 1t plus the summation of n1 to infinity of bn sine n omega 1t, but our a naught goes to 0 and our a n goes to 0, so those first two terms are gone. So we're just left with this last term over here, this summation here involving our b sub n. So we can do that there. We plug in our a naught equals 0, our a n equals 0, so our bn is equal to, now we plug in, we've just solved for our bn in the previous slide, 2 times p naught over n pi times the cosine of n pi minus 1, or bn is equal to 4 p naught over n pi for end values here of 1, 3, 5 for odd values there. So we can plug this back into our p of t equation here. So our p of t equation from up above here, now once we plug in our b sub n expression here, is p of t is equal to 4 p naught pi over pi times the summation from n equals 1, 3, 5 times our 1 over n times the sine of n times omega 1t. We plot these out. So what we have over here for our values. So our first one here is for p of t is equal to 4 p naught over pi times the sine of omega 1t. Then down below we have p of t is equal to our 4 p naught pi times the sine of omega 1t plus 1/3 sine 3 omega 1t. And then lastly here we have p of t is equal to 4 p naught over t times the sine of omega 1t plus 1/3 sine 3 omega 1t plus 1/5 times the sine of 5 omega 1t.